Hello, in this lesson, I'm going to do these 4 questions. I hope that we can finish it as in a reasonable amount of time. But if it's too long, then you just have to break it into different sessions to watch and follow. And you are more than welcome to do your own. And here, I just want to give you a reference so you can look it up and check for steps and answers for all of you. I encourage you to try to do all of these by yourself, maybe before watching what I have done here. But anyway, let's get started. The first question is probably one of the simplest one. We're just going to do repeat these 3 steps. I'm going to repeat these 3 steps, okay? We have explained all the reasons in the previous lesson, example number 1. So here we go. So on this one, right, you just have to identify what A is. A is 2 here, okay? And B is 5, okay? So our delta x would be B minus A, which is 5 minus 2 divided by n equals to 3 over n. And so A is 2, right? So we just plug in. We have derived these formula multiple times. So this is the time we can just use them. And all the A's are 2, okay? All the A's are 2. 2 delta x. Delta x is 3 over n, right? 3 over n, 1 times 3 over n. Times 3 over n. So all of these is plugged in. So we mainly need the i's one, right? We need the i's one. And plug in, and then we're going to put in this formula, okay? But this is because we're doing Riemann sum, we're taking limit part is going to be in the 3rd step. It's going to be in the 3rd step. So on the 2nd step, we're just going to do the Riemann sum. So composing the Riemann sum, okay, and we got our functions, and x sub I is already there, so x sub I will be replaced by this piece. So that's going to be just a copy and paste. And delta x is 3 over n. 3 over n. You can see we're just doing step 1, 2, 3, 1, 2, 3, right? So now we're on the 2nd step. On the 2nd step, and this is what we're going to do. Okay, we're going to plug in the function, right? The function is 4 minus 2x. Okay, so the function is, you can put it on the side, f of x equals to 4 minus 2x. And so when you are substituting, the function by what is defined, so this piece, this is your x, okay? So when we substitute as 2 plus I times 3 over n, and you can write it, okay, let me show you another way. Just put I here. Okay, so I'm going to replace this piece, which is in the place of x. On the other side, on the function, and replace x by is equal. So after we substitute this in the function, we got that's going to substitute this part, the function part. There. Okay? And so this step of substitution is critical because this is really the details we're getting into. Inside the parentheses, minus 2 distributed to 2, so that's going to be minus 4, right? Minus 4. And minus 2 times 3, that's going to be minus 6. 6 over n times I. All right, 4 minus 4, that makes 0. Okay, you want to leave some space for you to check your work. Okay, to check your work. And this will be 0. This will be 0, right? And this is a bracket. Double check. Negative 2 times 2 is negative 4. Negative 2 times 3 over ni is negative 6 over ni. So we got it right. And next, we're going to simplify. Okay? Simplify, we only have one term in the bracket. So we're going to multiply. So this is going to be the multiplication, right? And then negative 6 times 3 over n times n. So that's going to be, that part has nothing to do with I. So we're going to get 18 n squared is going to be taken out. Is going to be taken out. So this piece is out. And that piece is out. And this turned out to be, just we just use one of the formula, right? So that piece will be replaced by n times n plus 1 divided by 2. Okay, so we're setting ourselves up to take limit. We're setting ourselves up for taking limit. So here we're going to get negative 9, right? Negative 18 divided by 2, n squared divide into n plus 1. So the n times n plus 1. So one of the n is being reduced. So we got n over under n plus 1. And so this piece will be replaced by 1 plus 1 over n. So we are totally ready for taking the limit. We're totally ready for taking the limit. For shorthand notation, you may like to write this as a capital R under n, meaning Riemann sum. This is Riemann sum. Now we take limit. We take limit, okay? So taking limit of Riemann sum, well, you can have this attached. This is going to be limit, okay? The summation is ended up to be something like this. So replace it, okay? And that limit as n approaches infinity, this is going to be, whoops, I think this is 1. I'm sorry. This is 1, okay? This is 1. As n approaches infinity, so this is going to be 0. So the final answer is going to be a negative 9. So that's done. That's finished, okay? Let's look at the second question. We're going to follow similar steps, right? We're going to follow the same steps. Okay, let me just reduce this amount of work, right? We already have derived, them multiple times. So by this time, I think you guys are ready to use it, just ready to use it. So I'm going to use the second example. I'm going to apply this process to the second example. Okay, so the same step applied to the second example. Let me do it this way, okay? The second step, I'm sorry, on the second example, we did this in class, but now let's do it so it's recorded. Okay, let's do it, that's recorded. N sub interval delta x equals to b minus a, which is a 4 minus 1 over n. So that's going to be 3 over n. All right. and A is 1. So all of these are going to be 1. And delta x will be replaced by 3 over n. 3 over n. Okay? 3 over n and 3 over n. You can see all of these substitutions. You can simplify, but what we really need is this part. Okay, what we really need is this part. So you may like to write it as 1 plus 3 over n of I, because I is treated as a variable. Then we're gonna put in the Riemann sum equal, right? Before we take limit, substitute. Okay, put it back in f of n, right? The function is such. This is the function. Okay, this is the function. F of x. All right, and our x sub I is going to be in the place of x sub I. Okay, so we're going to do a bunch of substitution. So this x will be replacing that x, and all the x will be replaced by this new expression. And that's going to be f of, that's what we're going to use. Okay, equals to that whole piece will be replaced by its equal, which I'm going to put a bracket and put it inside. Delta x is 3 over n. Okay, 3 over n. And next, what are we going to do with the inside? Well, this piece will be treated as a plus b equals to a squared. Okay, so we're using this formula. A plus b squared, right, is a FOIL. But we know this formula very well. So you can use this formula 2ab plus b squared. Okay. So our a is 1, b is 3 over n multiply I. So this is the a plus b squared, right? So a is 1. A is 1, so everywhere a will be replaced by 1. Okay, b is this piece, 3 over n times I. So b is replaced by it, right? We're using this algebraic formula. And we're using this algebraic formula, and b is squared. Right, so this piece is going to be in the place of that piece. Okay, so let's bring them in. All right, so this piece is going to be replacing that squared piece. Minus 4 times 1 plus 3 over n. So this is 4 is going to be distributed to the inside of the parentheses. So we have minus 4, right? 4 times 1 minus 4 times 3. So this is going to be 12 times I, and the plus 2. And next, inside the bracket, we are going to combine like terms. We're going to combine like term. 1 square is 1, and this is 2, right? 2 times 3 is 6. So that's 2. And over here, we got a 1. We got a -4. So that's -3. Right? So that becomes -3. And there's a +2, +2 and -3. So this is a -1. Okay. 6 over n, 12 over n, multiply I. So these two are like terms. And after we combine them, we get a -6 over n times I. Okay? Now, square this piece. Okay, so we need to square 3. We need to square n. We need to square the I squared, of course. Now there's no like terms. There's no like terms. All right. We can also bring the 3 over n outside because it can be treated as a constant. Okay, it can be treated as constant. And then what? Next, we're going to split the summation. We're going to split the summation. Okay, so the summation will be splitted into this term. Okay, only on the part related to I, related to on this constant, and on this. You notice that I keep the constant outside. I keep the constant outside. Okay. So now we're about to use those formula. We're gonna use those formula. Okay. So 3 over n is kept outside on the inside the bracket. Okay, so we got the first piece, it will have 3 squared over n squared. That's 9 over n squared. Okay, multiply the summation of these. That's going to be n times n plus 1. If you don't remember the formula, it's okay. Just look it up. Okay, divided by 6. The second one, right, this is just n. This is just n. The third one is 6 over n. 6 over n, multiply the sum of n consecutive natural numbers, the first n natural numbers. And that equals to 2 under n times n plus 1. So now all the summations are being handled, and we are getting ready to take limits. Okay, this process really demands patience and being careful. Okay. By this time, I'm going to bring this 3 over n inside. Actually, probably I should not have taken it out anyway, right? So bring it inside and bring it inside. Okay, on hindsight, we probably should not have taken it out. If you didn't take out, that you didn't lose much. Okay. So how are we going to handle all of these? The easy part here, that's the 3. Okay. And this piece, okay, well, you can handle in any order you want. 6 divided by 2, right? And so this makes 9. And n times n, so this is going to make it n squared, right? So all of these just have a 9, okay? And on this piece, I'm going to write it as n times n, okay? So one of the n reduced with that n. So you probably already know this drill. So this whole piece is equals to 1 plus 1 over n. Okay. Now, this piece, 6, 3, reduce this. So this is 2, right? This 1 over n, reduce with this n here, right? And bring the 2 over here and bring n squared in the under these two. And of course, we can write n squared as n times n. And you pretty much know where we are heading. Okay. So this n would divide into n plus 1. So this time we're going to generate another 1 over 1 plus 1 over n. And this piece we're going to generate 2 plus 1 over n. Okay, 2 plus 1 over n. Okay, so these algebraic manipulations, now we're ready to take limit. Take a limit, okay, as limit as n approaches infinity. N approaches infinity, Riemann sum equals to, the limit is going to be on right here. Okay, so all that work, now we get to apply limit law. Okay, every piece involve n, the limit exists. So in the end, after we take limit as n approaches infinity, this is going to be 0, 0, 0. Okay, so this whole piece is 2 times 9 over 2. So this whole piece is 9. And this is 9. So in the end is a -3. Finished. In other words, so we should have a closure. That closure is that limit equals to -3. -3. Okay, so that was the second question in our plan. Let's look at the third question in our plan. Okay, third question. We do the third question and oh, wait. Did I copy the wrong question? I think this one was the wrong question. Hold on. It should be x raised to the power 3 minus 3x squared. Okay, so we get to use all the formula, all the summation formula related to the n. I think this one is about right. I'm sorry. Okay. This piece is going to be our next one. Okay, so we're going to use this process for the next piece. Okay, and delta x is going to be obviously 2 minus 0, so that's 2 over n. Okay, a equals 0. A equals 0, so all the a equals 0. 0. Delta x is 2 over n. So it looks like this one is easier. What really needed is for the x sub I, right? So x sub I. So at this point, you may like just to reduce the whole of these work just to x sub I. Because for step 2, you don't really need those other things, right? Because we use a summation notation. Okay, so I'm going to bring this limit part over here. R sub n. Okay, so we're going to compose the, so you can see the work can be reduced. Okay, the work can be reduced. You just take x sub I, r sub n. So this one is just 2 over n multiply I. And bring this to the function to the summation, we're going to substitute by the function, right? Because we know our function is 2x minus x raised to the power of 3. Okay? And now we're going to substitute x sub I. X sub I is this piece. There we go, right? And substitute x by x sub I. So this one over here will be substituted, and that's substituted, and that x is also substituted. All right. So this piece, this f of 2 over n sub I will be replaced by the whole of this, all of that. Okay? Delta x is 2 over n. Okay? And next, oops. And next, I'm just going to simplify, right? So 2 times 2 over n is a 4 over n. The parentheses is not needed. And 2 to this power 3 will be distributed to I to 2 to n raised to the power of 3. Let me make the fonts a bit larger. Sorry about that. Okay, I hope this is better. Okay. So this is 8. This is 8. I raised to the power 3. So next, we're going to distribute the 2 over n inside. Okay, so 2 over n will be brought inside. Brought inside, because we're about to separate the summation. This is going to be 8. N to the power 2, n squared, and this is going to be 16. And this is going to be n to the power of 4. So remove all of that, simplified, right? And next, we're going to distribute the summation in that way, okay? We use summation property. The summation is going to be, we leave the constant outside, and we leave the constant outside. So this piece is no more, and the bracket is no more. And plugging in, we get to use the other form, okay? This is the form we haven't got to use in our other example. So what is this? This means I raised to the power 3 as I runs from 1, if I equals to 1, so this is 1 plus 3. Oh, I'm sorry, 1 to the power 3. 2 to the power of 3. Okay, 3 to the power 3. And plus all the way when I equals to n, that's n to the power 3. What would that be equals to? And we have a formula for it. We have a formula for it. You should see it in your index card, okay? It's 2 under n times m plus 1. Okay, I'm looking at the textbook for that formula. So don't expect you to remember that formula, but if you use it often enough, of course, you can't help it. You will remember, but you still have access to the index cards. So now we're going to put everything together, okay? And that piece will be replaced by n times m plus 1 divided by 2. subtracting this other piece, 16 over n to the power 4, and this whole piece would be replaced by that. Boom. And summation is done. Simplify. 2, and that's 4. One of the n is gone, so this is n, right? So we're gonna bring the n under here, so that's just before. And so here we got 4 times 1 plus 1 over n. You know the drill. Similar. Minus, on this piece, what are we gonna do? We're gonna have 16 over n to the power 4. On the parentheses here, we are getting 2 squared is 4, right? N squared times n plus 1 squared. Okay, next, simplify. So 16 divided by 4, we have 4. N to the power 4, n squared, so we just have n squared. The other n squared on top will be removed. So we're gonna have n squared, we'll move it down here, and this is just 4. And that piece, I can write it as parentheses, right? Well, I'm going to put this, you can do any way you want, actually. There are multiple ways to do it. But I write it this way, and inside here, I'm going to replace it by that piece. Okay, so now ready to take limit. Ready to take limit, right? We're going to take limit of the Riemann sum, and the limit of Riemann sum is the whole of that piece. Okay, we should keep them in the bracket so it doesn't cause any confusion. It's a limit ready. Okay, so we can apply limit law. Applying limit law as n approaches infinity, this is 0, this is 0. So in the end, what do we get? This is a 4, right? This is a 4. 4 minus 4, we got 0. This limit is 0. You can use fundamental theorem of calculus part 2 to verify, okay? So let's get to the last question. This time we're going to use a simplified version of it. Okay, I'm going to use the simplified version of this partition Riemann sum, right? For the last question. Partition. The question we work with is this piece. All right. Right here, make it larger. By this time, we are pretty familiar with the formula, but this time, delta x is 1 over n. So this is 1 over n, and a is 0, so we got 1 over ni, right? Some people like to write it I over n. They are the same thing, so it doesn't make any difference, okay? So that I'm going to steal the Riemann sum representation here. Okay, so we're going to work on the Riemann sum. Working on the Riemann sum, of course, we know the function is this piece. Okay, this one has a little higher power. This just have a little higher power. So f of x is equals to that. Okay, so we're going to plug in I over n is x sub I. Okay, so I over n. So we substitute, we put this in place of x for every x in the expression. And put all of these in place of f of xi, which is going to be like this. And delta x is 1 over n. Okay? And simplify. And this turned out to be not so difficult a question. And we already did the harder questions, so this is no big deal, no big deal. So I raised to the power 3, okay? N raised to the power 3. I raised to the power 2, N raised to the power 2. I squared here, N squared, okay? I'm going to take the 1 over n, put it inside each one. So that is out. So now with that, we get n raised to the power 4. And this is n raised to the power 3. And you can see the advantage of, okay, so let me just keep going, okay? We're going to separate the summation. We're going to separate the summation into from one summation to 2 summations. So this one and that one. Okay? And then we are into these. The next part is I'm going to take 1 over n to the power 4 outside. Okay, so here we just have I raised to the power 3. N to the power 3 under, we're going to take it outside. Okay, so we just have I squared. And the rest we just put in the formula. Okay, we just put in the formula. We just used, okay, so refer to your index card if we need that. Okay, so this is going to be 2 n times n plus 1. And all of it is being squared. Subtracting 3 over n raised to the power 3. And the formula we needed is 6 under n times n plus 1, 2n plus 1. So you may notice actually things get easier because a lot of the part get to be repetitive, right? So we're going to take the squares inside, right? So this is going to be 4, and this is going to be n squared, and this piece is going to be n squared. Bracket is no more, we don't need it anymore. So this is n squared, and this n squared is taken away, being reduced, and bring the 1, 4 here, n squared under. I find myself repeating myself. Okay, so this is 1, and this is 2, so bring the 2 here, right? Bring n to the power 3 over, wait, so n to the power 3. So this n, we take away, one of the n under. So n squared we can write as n times n, sorry, n times n. So you already know the trick. Okay, let's do it one more time. This piece, we're going to rewrite it as 1 plus 1 over n squared. Okay, because from here, we are basically, okay, I think you got it. You can get it. Okay, so m plus 1 divided by n, m plus 1 divided by n will be replaced by 1 plus 1 over n. And this piece will be replaced by 2 plus 1 over n. We've done this so many times. If you need more explanation, please let me know. Okay, I think I can finish this in reasonable amount of time. Because you can see this is all routine, right? Oh no, we don't need this step. We don't need this repeat. Last step, 1, 2, 3, limit. Okay, limit as n approaches infinity, right? Riemann sum equals to, so this limit on that whole piece, which is limit ready. As n approaches infinity, we can apply limit law because each piece there's n and limit exists. Okay, so on this piece, the limit as n approaches infinity, this is 0, 0, 0. And we're almost done. We are almost done. Okay, so this is 1, and this is 2, and that's equals to 1. So in the end, we get negative 3/4. That's it. Okay, so this question, the final answer is negative 3/4. So we've done all of these questions from our homework on that related section. See, I forgot which section. You know what I'm talking about. Thank you for watching. Okay, if you wish to improve your algebraic skills, and this is the practice you can follow, and you can do it. Okay, you can do it without my guidance, but if you need my guidance, and here it is. Thank you for watching.